Okay, also in this section, we're talking about some fundamental identities that we're going to need to know. And these concepts have come up a little bit, but we haven't really addressed them a ton. So reciprocal identities are basically identities that will apply to reciprocal functions, and any powers will apply. So I'll talk about that in just a second. So here we need to remember that the sine of theta is the same thing as 1 over the cosecant of theta. Because if this is the sine, you essentially have 1 over the sine, which we know when we're dividing fractions, this flips back up to the top. Okay? So this is the same thing. And when I say that any power will apply, what I'm saying is that if I have the sine of theta squared, this is the same thing as 1 over the cosecant of theta, which is this, squared, or it could be cubed or to the 4th power or to the 83rd power, it doesn't matter. So now with the cosecant, if the sine is 1 over the cosecant is 1 over the sine of theta. Okay, and again, any power will apply, so I'll give you one more example. The cosecant cubed of theta. Now you notice I wrote these differently. This means the same thing. This is the same thing as 1 over the sine cubed of theta. Okay. Cosine is 1 over the secant of theta. So that means secant is 1 over the cosine of theta. And these will all be used. Tangent is 1 over the cotangent. And cotangent is 1 over the tangent of theta. Okay, so these are all identities that you need to make sure you understand. Now, I just want to point one thing out. If you have the sine of theta squared, this square actually goes right here. So this is the same thing as the sine squared of theta. So in our calculator, it won't let us put the square here, so we need to type it in like this. But this is not the same thing as the sine of theta squared. These are not equal, so you need to make sure that you understand this. This right here, both of these, mean sine of theta times the sine of theta. This means the sine of theta times theta. Totally different. Okay? Okay, then we have quotient identities, which any power also applies here. And something that you need to think about, this comes from our unit circle, is that the tangent of theta is the same thing as y over x. And remember, y represented our sine, okay, and x was our cosine. So remember, y is your opposite over adjacent on the unit circle, and this, or excuse me, opposite over hypotenuse, and this is adjacent over hypotenuse. Okay, so now we're using trig functions instead of letters. So when I write this right here, the tangent is going to be the same thing as the sine of theta over the cosine of theta. So if any power will apply, if I said to you we have the tangent squared of theta, this would be the same thing as the sine squared of theta over the cosine squared of theta. Any power applies. So this could be a 3rd power, a 12th power, 72nd power, it doesn't matter. So if the tangent is sine over cosine and cotangent is the reciprocal function of tangent, all you have to do is flip this over. So this is the cosine of theta over the sine of theta, and because any powers apply, I'm just going to show it again. Cotangent, let's say to the 4th of theta, is the same thing as the cosine to the 4th over the sine to the 4th. These are just examples. These are the identities right here. Okay? All right, so how do we use this? I'm going to show you two things. One is non-calculator and one is calculator. So here for the non-calculator, we have the sine is negative and the cosine is negative. So this is where we have to go back and use that thought process, like where am I? So that means because sine and cosine are both negative and this is on the same triangle, we are in the 3rd quadrant. So if you recall, sine is y over r and cosine is x over r. That means if they're on the same triangle, the radius has to be the same, and it is. So what this means is whatever's in the numerator for sine is my y and cosine my x. Now remember, your r, which is your radius, cannot be negative, so what that means is the negative belongs to the numerator. So that means I have my x coordinate of -2 square root of 5, my y coordinate of -square root of 5, and my r is equal to 5. Okay, and this comes from what we did on the unit circle, but now we're just pulling this apart. And the reason why is because it says find the exact value of the 4 remaining trig functions. So here we have sine and cosine, so that means we want the cosecant of theta, okay, the secant of theta, and then we have the tangent of theta and the cotangent of theta. Okay, so now what we want to do is we could either flip these over and rationalize, okay, which is something that we're going to have to do. So when I take a look, if I flip this over, because these two are the reciprocals, this is negative 5 over the square root of 5, which when I rationalize by multiplying by the square root of 5 over the square root of 5, this becomes negative 5 square root of 5 over 5. You have to reduce, so that means the cosecant is equal to negative square root of 5 after all that. And I know some of you can do this in your head, and that's totally fine. Secant of theta is now going to be negative 5 over 2 square root of 5. So when I multiply by square root of 5 over square root of 5, I end up with negative 5 square root of 5 over 2 times 5. I'm just going to write it like this because now I can reduce this. So this is equal to negative square root of 5 over 2. Okay, now, in terms of the tangent, what we have is y over x. Remember, so the tangent of theta is equal to y over x. So that means I have this over this. So I'm going to write it first, which is negative square root of 5 over negative 2 square root of 5. Okay, so good news. The negatives become positive, and those 5s cancel, square root of 5s cancel out. I'm left with a positive 1 in the numerator and a 2 in the denominator. So this makes my life so much easier when I have to find the cotangent, because all I need to do is take the reciprocal. So this is 2. And now you're done. Okay? All right, so what is different about C is the fact that these values are decimal, so we need to use a calculator, and I'm going to show you how to do this quickly in the calculator, but something you need to think about, just like what we did over here, the sine of theta is y over r, cosine is x over r, and we wrote down all of our values. So here, if you don't see anything, this is implied to be over 1. So what this means is that this is my y, this is my x, and my r value is equal to 1. So if I'm looking to find the cosecant of theta, this is going to be 1 over 0.6428, but we want to find the decimal. So in my calculator, I can do one of two things. I can say, okay, 1 divided by 0.6428, that's going to give me the answer of 1.5557. Or something else that we can do. So everybody watch. Here, if the cosecant of theta is 1 over the sine of theta, this is the same thing as, and we talked about this in a lot of classes, when I bring this to the top, sine to the negative 1 of theta. So what I can do is type into my calculator, I need to find the key, point, okay, so if the sine of theta is this, if I take that to the negative first power, 0.6428 to the negative 1, that's going to push that into the bottom, which implies this right here. So watch, 0.6428, here's my x to the negative 1 key right here. So when I press that, this is what I get the same answer. Now if you forget, just do it the way that we did it. So now here I need the secant of theta, which is going to be 1 over 0.7660. Okay, so I'm just going to take 0.7660. This is the answer right here, 1.3055. And now we need our tangent. So the tangent of theta is going to be sine of theta over the cosine of theta, which is going to be 0.6428 over 0.7660. So I'm going to do that in my calculator. So this is my answer of 0.8392. And then I need to find the cotangent. So I'm going to draw one here. Cotangent of theta. So I can think about it like this. It's either 1 over 0.8392 or 0.8392 to the negative first. It does not matter how you do it. There's 1, or 1 divided by 0.8392. They are exactly the same. Okay, you're going to get the same answer.